Thank you, appreciate it. I'm just gonna set this down. All right, can everybody hear me okay? I like to yell, I don't like to use a microphone. All right, solid. So thank you for the introduction, Josh. So just real quick, again, my name is Tommy Butts, grew up in Wisconsin. I will warn you in advance, I have a very strange accent now, all right? So I grew up here in Wisconsin, so I still have some of the Wisconsin, all right? I was in western Nebraska for 3.5 years though, so I've got a little bit of cowboy culture from that. And then the past 5.5 years, I was actually in Arkansas as a faculty member down there. So you'll probably catch a y'all today. You'll probably catch a fixin' to at some point, all right? So just be aware if you don't understand something, I get it, just ask, all right? And I'll try and rephrase it, all right? So please feel free. Also, throughout today, whatever we're talking about, please feel free to ask questions at any time. Throw stuff at me. I'm good with any of that, all right? I'd rather talk about what y'all want to talk about than just me spewing random slides and stuff, okay? So feel free to ask anytime. And then the last thing right before I get started, I want to ask y'all a question just so I have a good idea. What is everybody's primary position that y'all are doing? How many farmers do we have here? Okay. How many like agronomists, sales folks? Okay, the bulk. Do we have any like crop consultants? Okay, a few there too. So a good mix of consultants, agronomists, and then a handful of farmers. All right. A lot of what I'm going to talk about today will apply across the board. It may not sound like it, and if you have questions about that, we can chat about it. But I'm going to talk in this presentation in particular a lot about nozzles and setting up sprayers correctly and making sure that we're using some of the basic technology in the right way to get the most out of our weed control tactics. Now, as an agronomist, right, a lot of times, or a consultant, I'll get looked at and be like, well, I don't handle the sprayer, I don't do anything there, I pass my rec along, and that's the end of it. No, okay? That's the conversation that I want to bring out today is opening lines of communication. Even as a consultant or an agronomist, this stuff is an important thing to know. And if you can start having conversations with the applicators, and just so you know, conversation's a two-way street, all right? We're not telling the applicators exactly what to do, but we can have a two-way street conversation about some different things, okay? That everything can do a whole lot better down the road. All right, everybody clear on that? Can I get off my soapbox? All right, perfect. All right, so let's get started. Down arrow, right? Okay, so first and foremost, the thing you need to know about me, I'm a huge football fan. Okay, so I try and tie everything back to sports in some form or fashion, so I'll have a handful of different sports-related things today. But this is one of the best ways that I can demonstrate what we're going to talk about today and why it's important. Now, I apologize in advance. It is an Arkansas football reference. I will have some Wisconsin, at least one Wisconsin football reference later today, though. All right? But this is the best way that I can possibly explain why the stuff we're going to talk about is important, all right? So we've got our pests that we're trying to tackle. If we do a whole bunch of things wrong, low spray volumes, poor coverage, wrong nozzles and droplet size, application setup errors, those pests just keep on chugging and running and getting to that end zone. And then when they do that, especially in weeds, they're reproducing, you know, have more seeds, you're dealing with them down the road even worse, right? So I can't describe it any better than that video right there. That's what happens when we throw all these wrong things at it. Those pests just keep on trucking right through it. All right? Also, I would like to mention, the week after O'Grady did this play, Arkansas football cut him. Yes. Good job, Arkansas. All right, moving on. So the first thing I want to hit on. Now, my title was technology, right? So a lot of people think we're going to start talking right off the gates about all the fancy new things, the drones and the See & Sprays and the One Smart sprays and all of that. Let me tell you, there's a whole lot of technology that we need to get right first before we ever get to that. And that's what I want to talk about on the front end. So the first technology thing I want to talk about is spray options. And that happens to be spray volume and droplet size or nozzle selection. Okay? We're going to take a step back and talk about some of that first. So the first thing I want to ask y'all is Liberty herbicide. Is it a contact or a systemic? Contact, right? No trick questions today. That's a lie. I will have trick questions. Okay. Do you think spray volume matters for Liberty herbicide? Yes. Lower, higher, better? Higher is better. I would agree. The picture helps show that too, right? 5 versus 20 GPA. Now, that 20 GPA don't look excellent though, does it? Right? There's still problems there, but a higher spray volume is helping us out. Let's go to dicamba. Is that a contact or a systemic herbicide? Systemic, it's exactly right. It moves through the plant to kill it, right? Does spray volume matter for that? Not as much. I heard kind of mixed results. Yeses and no's and hin and haw and about right there. The answer is yes, it does matter. 20 GPA does better than 5 GPA still, right? More volume gets us more droplets, which gets us more opportunities to try and kill those weeds. Okay? Now, I will say 20 GPA still doesn't look excellent here, right? What's missing from this conversation on when I just throw these pictures up of spray volume? What? Nozzle, right? Droplet size. I'm going to tell you right now, if anybody tells you this is the ultimate spray volume that you need to be using every time, you can walk out of that talk. I give you permission. All right? There should always be hand in hand talking about the nozzle or droplet size with the spray volume. Those two things go hand in hand together. Okay? So if we talk about droplet size instead, let's talk about Liberty again, that contact herbicide. Does droplet size matter for that? 100%. So we've got a whole range of droplet sizes up here from 150 microns, which is a fine spray, all the way up to 900, which is an ultra coarse. And you can see drastic changes in droplet size treatments, right? And I would like to emphasize this one right here, 300 micron droplet size at 5 gallons per acre. Looks good. Now, please don't walk away and say that Purdue Extension's recommendation is to spray Liberty at 5 GPA. Okay, that is not what I'm saying. Okay? But what I am saying is if you can select the right nozzle, get the right droplet size out there, you can do some really good work. And then if you also pair this with a little bit higher spray volume, you are mitigating a whole lot of risk to maximize that application, right? So I wanted to emphasize that. Okay, next. Got to talk about the dicamba front, the systemic herbicide, right? Does droplet size matter for that? I see some yeses. Are you sure? Systemic. We're spraying it with massive droplet sizes, right? Shouldn't matter. Does it matter? Guys are smart today. All right, it does matter, right? Now, it doesn't matter as much. It got brought up with the spray volume, right? So it doesn't matter quite as much. You can see from 300 microns to 750, really there's no major difference. So then why not spray it at 750? Because our weed control didn't get affected and we can reduce drift potential, right? Which we'll talk about in a second. But so that's good. What I do like to highlight on this one though, if you look at this 900 micron treatment right here, how does that look for weed control?
Yeah.
I can actually tell you this was a study we did in Nebraska. That site here in Nebraska, that 900 micron treatment was not statistically different from our non-treated control. So what that means is we could have sprayed absolutely nothing and done just as well as a labeled rate of dicamba at that size of a droplet. That's crazy to think about, right? Now, this 900 micron size too, it is a little large for what we typically use in our ag applications, but it's not unheard of, okay? We can get there with some big, large droplet producing nozzles. I'll pick on T-Jet, right? The TTI can get us there, especially if you pair it all of a sudden with a drift reducing adjuvant. We can get over that size. And so we can start running into issues because we're teeter-tottering on this upper limit, okay? But I will say this was, again, talk about the two together, this was at only 5 GPA. So if we're spraying with these large droplet producing nozzles, especially in things like the dicamba and the enlist systems where we have to reduce drift, we're relegated to certain nozzles, spray volume becomes even more important there because we're limited on what size droplets we can choose, right? Go ahead.
You air inductor tips falling.
So that's a good question. So there's a whole gamut with droplet sizes with different nozzles. There's even some non-air induction tips, but they can still get you up to that 900 micron size. So like if you've heard of Wilger, they get used a lot on the Paulson sprayers. They can get you up there with certain ones too. But like just some common ones, I always like to use T-Jet because typically those are fairly common. An XR flat fan is generally somewhere in that 150 to 300 zone, right? Like the fine to medium. The AIXR is always my middle of the road nozzle. That's somewhere between the 300 to 600, depending on size and pressure and things. And then the TTI gets you up here in this like 750, 800 type range. And the AIXR and the TTI would both be air induction tips then. Yeah.
But
Yeah.
we've also like so it's not good.
No. So this was using a pulse width modulation sprayer. And so we had done some work in the lab with pressure and nozzle combinations to get these specific droplet sizes. So pressures varied a little bit. The rate is obviously all the same. So it was all 5 GPa. The rate of chemical is all the same. It's just basically we had to manipulate pressure to get the sizes. Yeah. Any other questions? All right. Is everybody clear on that front? Okay. Real quick, I just also wanted to highlight, while we're talking about kind of the coverage and the balance between those nozzles, it's kind of a good segue to talk about the air induction tips and that kind of thing. I've got 3 different coverage cards here that I always like to show. Okay. Can anybody tell me what 3 spray volumes I used on these 3 different cards? Everybody see that? So I got this one right here, the one in the middle, and the one on the left side. What spray volumes are each of those at? All the same. Would I really do that to you? Is that what everybody's going to go with? They're all the same? I'm going to pack it up and leave, Rodrigo. What am I doing here? Oh, anyway, they are all the same. They are. Now, the real question is, what are they? They are all the same, but what are they?
Wait. What?
20 GPA. Anybody else got a guess?
15.
15 GPA. Anybody else? 12 GPA? Wrong, wrong, and wrong. We're at 10 GPA right here. This is 10 GPA. So this is an XR flat fan nozzle, so fine droplet size, medium droplet size, I should say, right? This one is the AIXR nozzle. Okay, so we're talking like a coarse spray generally, but 10 GPA. This is at TTI, an ultra coarse spray, 10 GPA. The coverages on these things go from, I got to remember now what it is. I want to say it's, I think it's like 20, 30, 40%, if I remember right. So the TTI was like 20%. This was 30%. This was 40%. Pretty sure that's what it was. Okay. I do like to always show this though, because this will get into some of the technology later. And I know we've got a drone operator here and we're operating at some low volumes with the drones and things and airplanes and helicopters and stuff. Here we've got, oh, whoops, wait a minute. Ha! I lied to you. This was the 10 GPA one. I tricked you. This one right here is actually 5 GPA out of that XR flat fan. And we were guessing 15 and 20 out of it. Or 12, I guess somebody said 12, right? So again, this balance between volume and droplet size, if you pick the right droplet size, you can still get some really good coverage. And actually this one, the 5 GPA treatment with this XR was equivalent to 10 GPA out of this TTI nozzle. So you can balance it out a little bit with droplet size and volume again, right? So when we start talking about spray drones later and I get into some of this coverage and weed control stuff, this is partially at play with some of the droplets that are coming out of those things. Okay, even at low volumes, we can still kind of get there. So that's a good question. So I should repeat. The question was any kind of coverage cards or data with surfactants and stuff with that part of it. So generally speaking, the coverage part of surfactants doesn't necessarily change. It spreads it out more, which helps get more absorption because it's helping droplets kind of stay on a leaf surface, spread it out. It allows more surface area for it to be absorbed. So like the coverage part doesn't necessarily change. You're still kind of getting the same number of droplets there, I guess is what I'm kind of getting at. What does change, it would change our coverage number, but in reality, it's not changing what we're concerned with from a coverage standpoint. What it's changing is the fact is that you're spreading it out, it can absorb more, and it's retained more. But like, it would be a biased result, in my opinion, on what like the coverage number actually says. What I will tell you about surfactants, though, too, what surfactants are doing that they can improve coverage is not necessarily that spreading factor. Generally speaking, surfactants always lower your droplet size. And so when you end up with a smaller droplet size, you end up with more droplets in a fixed volume for more coverage. So Surfactants will, in fact, get you more coverage, but it's more because it changes in the droplet size and that spreading effect. The spreading effect helps droplets just stay on and kind of spread out to help get absorbed, but it's not really changing the coverage part. Does that make sense? Okay. Right. So, like, coverage in theory is basically just based on your number of droplets and, you know, how it's impacting and retained and stuff like that. And so, like, with a surfactant, it's not necessarily changing what's getting there, but it'll change the spread factor part of it. And that would bias a coverage estimate, but it's not really changing how much you have there. You still have the same deposition there. It's just changed where it lays. Yeah. All right. Any other questions? All right. I already lost my clicker now. Okay, here we go. So moving on from that conversation, now you got to talk about the spray drift component, right? Because basically, if you listen to any of that, the recommendation should be, well, let's use an XR nozzle, fog it out there, right, at a high spray volume. No, Purdue is not saying that, okay? So now we got to talk about the spray drift balancing act. So I always like to say there's 4 main things that affect particle drift. Who knows what those 4 things are? What's the number 1 thing that affects spray drift? Oh, we got some other things. Now we got some dissension amongst the ranks. It's going to be a mutiny. What's the number 1 thing? Now we're saying multiple things. We're hedging bets. Oh, my goodness. Here's where I make my money back. There we go. No, okay. Anybody have a consensus what the number 1 thing was? Should have stuck with your guns. It's wind speed and wind direction. Wind speed drastically affects our drifts more than any other factor that we have out there. There was some data that showed when wind speed doubled from like 5 to 10 miles an hour, I think. And 10 miles an hour is still a good spray day, right? When wind speed doubled from 5 to 10 miles an hour, downwind spray drift increased by like 700%. It's a ton. Wind speed's a huge deal, right? What's the second factor that affects drift? The second biggest factor?
Yes.
What's that? No, still coming. It's not the second biggest factor still. Pressure affects droplet size. Boom height. Hey, there we go. Who is that? Yeah, gold star for you today. Boom height is correct. That is the next one. When boom height doubled from 18 to 36 inches, when guys are spraying at 36 inches, it's a safe place, guys. We can be honest with each other, all right? When it doubled from 18 to 36 inches, downwind drift increased by 350%. How many people have watched those spray rigs going through like an eagle in the field? Its wings just keep getting up there, right? Seen it? There's a sprayer in Arkansas that was going by on the road, and I could have stepped out and walked underneath the boom and still had to like jump NBA style to try and hit the boom. Okay? So that's the next problem. The next one I'll give you is distance to susceptible vegetation, buffer zones, right? So that doesn't really change drift, but it changes what gets affected by drift, right? If you have a buffer zone, you don't have the spray hitting those susceptible species, you can reduce your off-target impact, okay? And then we get to number 4. So the 4th out of the big 4 is now droplet size, but droplet size always likes to get brought up first, right? Why does it get brought up first? It's the only one we can really control, right? That's exactly right. We can't affect wind speed. Wind speed's going to blow what it is. We got hundreds and thousands of acres to get across. We're going to be rolling even if it's blowing 20 miles an hour. Don't call Rodrigo and I and tell us that, but we know it's going to happen, okay? So we got to deal with that. Boom height and flight height, that is relatively fixed, okay? So if you look in the TJAC catalog, it will tell you a recommended boom height for your specific nozzles and your nozzle spacing to get the correct coverage. So technically speaking, we really can't affect that other than slowing down and making sure our boom height's not 10 feet in the air. We get it down to where it's supposed to be, right? And then the buffer zone part, well, that's either label mandated or, you know, we don't know what is around us for susceptible vegetation, that kind of thing. So droplet size is the one thing we can actually manage. So just a little bit of background info. We talked about using a bigger droplet size to help reduce drift. You can see here, this is a little bit of data from North Dakota where they just kind of theoretically calculated. I mentioned basically from 100 microns to 1,000 microns is about where we're at for agricultural applications. So if you have a fine spray with 100 micron size, it'll take 10 seconds for that droplet to land to the target. And in that 10 seconds, in a 3-mile-an-hour wind, that droplet can travel 50 feet off target. 3-mile-an-hour wind, which none of us are ever spraying in, us included on the research side. Okay? Now, if you jump that droplet size up to 1,000 microns, so we're getting, even past that TTI range a little bit, that takes less than 1 second to fall 10 feet, and it can move off target less than 5 feet in that 3-mile-an-hour wind. So bigger droplet sizes help reduce drift. So we're playing this balancing act of good coverage, reducing drift, trying to implement a higher spray volume to make up for some of this. This is the world that we're living in. Okay? Now, I did want to mention real quick, because like I said, a lot of you are agronomist consultants, want to talk to your applicators about trying to reduce drift potential. So I've got this little, example of how we can reduce drift, all right, or drift potential, I should say. So up here, you'll notice a droplet spectrum from an XR 110025 nozzle at 60 PSI using water. Right here, this black bar indicates our driftable fines or our high drift potential, and it's about 26% of that application is considered highly driftable. That's a lot. Let me tell you, that's a lot of that spray that's potentially moving off target. If you look at that application, what would y'all recommend to do to reduce drift right off the bat? Reduce pressure. 100% agree, right? So you drop the pressure down to 30 PSI, you keep the same nozzle, and you reduce fines from 26% down to 15%. That's good. What did that cost you? See a few people saying nothing. That's not the correct answer. Costs you volume, which costs you time and efficiency, right? You just cut your output in half. So now you're losing on the efficiency front, okay? Well, how do we get our efficiency back? How can we get our time back and reduce drift potential now? Tip size, it's exactly right. So we jump from an 0.25, we double it to an 0.5. So now we got our efficiency back, we're back up to speed, we've reduced our pressure, and now again we reduced our drift potential down to 7.6%. What's the next thing we can do to reduce drift potential even further? This is where I start stumping people. So you could, I tend to always look at this like a pair of binoculars. So you have a coarse adjustment knob and a fine adjustment knob, right? The coarse adjustment knob is going to be nozzle selection. Hint, hint, wink, wink, okay? The fine adjustment knob is the adjuvant side of things. And so you can do a lot more damage, get there a lot closer with the nozzle selection. The adjuvant fine tunes it at the very end. So not a wrong idea, but it's just kind of down the road yet, right? So the hint I gave you is changing the nozzle type, right? So instead of an XR nozzle, we switch to a TT nozzle, so a turbo T-jet, and it drops us down even more to 2.8% fines. And then if we add the, some of the latest nozzle technology, the air induction part, and we move to a TTI nozzle, now all of a sudden we've dropped all the way down to 0.2% fines. So we started at 26% fines, 26% potential highly driftable, and with literally one change of the nozzles, all we would have had to do, we can drop all the way down to 0.2% high potential for drift. That's really big. That's really important to talk about. Okay? Again, have those conversations with the applicators that, hey, we got to start maybe thinking about getting some new nozzles on this thing instead of running the ones that we were still running in 1985. Okay? So nozzles are a big deal for trying to reduce drift. Adjuvants can then help on the back end and fine tune us even a little bit more. For drift, you're not going to fine tune it. I would fine tune this though, hopefully for like a surfactant or an oil or something else, right? To help with either the spread or the retention or other things. Because you get this big of a droplet size, you're going to start running into other issues for the efficacy standpoint. So you'll fine tune it for other reasons. The drift part, you're probably pretty well maxed out at that point. It's a good question.
But it increases your PSI again.
So if you increase the PSI again, you're going to increase or decrease your droplet size again. With the TTI, it doesn't change drastically. Like, I don't have the number, so don't quote me on this number as gospel, but you know, you might go from 0.2% if you jump up to say 60 psi, maybe you go to 1%. Maybe. Would y'all agree with that? Okay. Close enough. Okay. Yes, I mean, and your speed is already up there just with your nozzle size too, you know, but some guys like to run higher pressures. Honestly, sometimes I'm a higher pressure guy because I think we do better with our spray systems with higher pressure. So yeah, I wouldn't disagree. To me, the main thing is that nozzle selection, right? I think that is the biggest driver for most of this over a lot of these other things. I think pressure can fine tune some things, kind of like we talked about with adjuvants. Yep. All right, any other questions? More coverage, if you're at the same concentration, is always better. Except for maybe crop injury. If we start working in crop injury into this, that's another gamut too, right? Because more coverage with crop injury, say cobra on beans, you get more coverage, you're gonna burn them even more, right? But as far as weed control goes, no, less coverage with the same concentration is not going to ever be better. Now, the conversation though goes, if you're doing less volume, most of the time you have a more concentrated droplet, then there is potential. I don't want to say that you can get better weed control, but you can get equivalent weed control. We'll talk about this in a little bit with some drone applications. So Roundup is one of the best examples. It actually does better in low volumes with more concentrated droplets. Like if people could run Roundup at 3 GPA all the time, it actually does better. You run into other problems kind of on the back end though, like the coverage part and stuff like that. Like if you can make sure the droplets are landing and sticking and everything else, 3 GPA will do better with Roundup, but there's different caveats in there. But yes, with more concentrated droplets in less volume, there are certain herbicides that can do just well. I actually will show you from a drone study, you'd be pleasantly surprised even with a contact like gramoxone at a low volume, that it can still do some pretty good weed control work. So again, it's always that balancing act between droplet size and spray volume. I don't want to just push 20 GPA on y'all. Trust me. I try and tell guys you don't need to run 20 GPA all the time. But if you get shoved into a big droplet size, you tend to need more volume at that point to get enough coverage, enough droplets landing to get your weed control. Does that all make sense? Does that answer? Okay. That's a very good question. I appreciate that. We're going to do a whole diversion on this one. All right. No, you're good. So it's a very good question because I hear this all the time too. Okay. Because a lot of times too, I'll get told or asked the question or just told, well, I need to jack up my pressure to force those droplets down in the canopy. Right? Everybody heard that before? Okay. It's somewhat of a fallacy, and it also is very dependent on what your goal of the application is. Okay, so there's two things I'll talk about here. So the first thing I'll talk about, if you want to penetrate into a canopy, bigger droplet size is always better. Bigger droplets have more mass and technically more terminal velocity. They are going to force their way through a canopy better than a small droplet size, even at a high pressure, right? Because those small droplets, you may be pumping it at 80 psi, but those things hit their terminal velocity within like 6 inches of the dang nozzle, and at that point, they are way lower speed because they don't have much mass to them. So larger droplets are better to penetrate the canopy no matter what, okay? But now the conversation comes in, particularly with fungicides. This is a really big deal, is where's the target at, okay? So if we're talking corn, and we're trying to get down to the ear or the ear leaf, and you got all this canopy above it, right? You're gonna want a bigger droplet size to force it through all of that. And even though it's a bigger size, you're going to be better off because it's making its way through and getting down to where it needs to be. A finer spray will get caught all on the top and just won't ever make it down to that ear leaf. Now the conversation changes though. Say we go to wheat and we talk about like wheat head scab. You want all of that spray to literally sit at the top and go nowhere else, right? So then a really fine spray with low velocity is a lot better because you get it to just sit right there on top and it's not trying to go anywhere. So that's the balancing act is what's your goal? Where do you got to get the droplets to? And then from there. But I will say if you're trying to actually penetrate, larger droplets are always a better way to go. Very good question. So the question was droplet size versus pre's versus posts. Much, much, much more efficient for posts, right? Much more required for posts. There's been some research done on pre's and the different things. Generally, it's really hit or miss. You know, sometimes you will get a result that shows, yeah, it matters. Sometimes you won't. It kind of depends on what your environment is, right? If you're no-till, if you're tilled and you got clods, if it's a nice fine soil type, depends on what kind of precipitation and activating rainfall and moisture you get. So it's kind of all over the board. So generally speaking, like broad general extension recommendation, I generally say for pre's, it doesn't matter. You know, I like a bigger droplet size because it reduces drift. If you've got like a cover crop that you're trying to get it down through that residue, generally a bigger droplet size is probably better for some of that. So pre's, I generally say, let's run a bigger size and we'll be good. Post is where it gets much more picky on what you want to do. Yeah, good question. So almost every night we have temperature inversions. I mean, it's basically like 90% of the time, pretty much, you have a temperature inversion at night. Now, it depends on where in the atmosphere, right? It may be right at the ground. It may be 10 feet in the air, something else. But yes, almost every single night there's a temperature inversion. Dusk and dawn are like almost the worst, terrible times to be trying to apply because you're getting into that window. The reason temperature inversions are such a big deal is because basically your wind, your air movement is not moving, and you have this layer where it's just stuck. And so if you spray, those droplets will hit that layer and then just sit there. They can't drop. They can't fall out of the sky. Well, and then if even in just a 3-mile-an-hour wind, right, where it's just maybe lightly moving, as long as that layer is there, those droplets just stay suspended, and it'll just move all night until the temperature finally changes and they can fall out, and that'll land wherever, whenever, whatever, right? So they are a big deal. Again, the reason we don't talk about them a lot is because it's basically at night. We rarely see them during the middle of the days. And I can tell you from a weed science standpoint, we don't want folks spraying at night anyway. We lose weed control by spraying at night. You need to spray in the day. Yes. So you know, again, watch out for them. It is a big thing, especially now when we're getting into the drone world. The manned pilots have known about inversions their entire lives. If you really want to learn about inversions, go talk to a pilot, okay? Because they have to know about it, because that causes a very turbulent ride in their plane if they are flying through an inversion. So they have dealt with inversions their entire lives. They are way more advanced on this than any of the rest of us when it comes to this. But basically, you just got to know almost every night you're going to have one. A lot of places, I don't know if Wisconsin has like a mesonet right now. So, okay, I was going to say, so you can look up some different mesonets and see, and they'll trigger, you know, like, hey, we have an inversion at this point, you know, and you can start setting up some alerts and stuff like that. So that's a really good way to monitor it. But my extension side of things is just every night you're basically going to have an inversion. We lose weed control anyway by spraying at night. We got to just spray during the day and try and cover the acres when we can cover the acres at that point. But I will also say the other recommendation I normally give with inversions is, who here would rather spray in a 15-mile-an-hour wind versus a 2 to 3 mile an hour wind? You and me, Dan. I would pick a 15-mile-an-hour wind every day of the week over a 2 to 3 mile an hour wind. Do you know why? Well, that's fair. More spray days. If it's blowing 15 miles an hour, if it's blowing 15 miles an hour, that wind direction's probably not changing, right? It's going one way, and you know exactly where it's going. You can manage your stuff a whole lot better when you know exactly where it's going. You can leave a buffer zone, come back and hit a pass another day. You know, maybe you choose, I can't spray that field today, but I can go spray these fields. You can do some things. When it's 2 to 3 miles an hour, a lot of times you might be in an inversion, and then that stuff can go miles. The wind direction's probably shifting on you, so you may think you're safe because it initially started blowing, you know, to the south, and all of a sudden it switches and blows to the north, and you smack your neighbor up there. Like I said, I would choose a higher wind speed every day of the week because I know where it's going. I can manage it better than when it's that real low 0 to 3 mile an hour wind speed. And a lot of our labels anymore now are starting to go to the standpoint of you can't spray when it's less than 3 anyway, right? Okay. These are all great questions. I appreciate this. Anything else before I move on? All right. Let's crank through some things here quick. Nozzles. I'll go through this relatively fast. The main thing on nozzles that I want to get y'all to know about, though, so when you call Rodrigo or me or anybody else, you can give us some solid information, okay? How many people, if you're calling and you're trying to get a nozzle recommendation and you're trying to explain what your sprayer setup is, how many people can legitimately say what nozzle you have on the sprayer? Okay, I see about 5 to 10 hands maybe. How many of the rest of you would call and tell me, I got the red one? Please be fair and raise your hands. Trust me, that is the #1 response I get. I've got the red ones. Okay? I've got my nozzle kit up here that I wanted to show you. I have no 2 similar nozzles in this kit. See how many red ones I got in there? You basically tell me nothing when you tell me I got the red one. All right? So what the red tells you is your flow rate. So I'll just throw these 3 things up here. All these nozzles will give you basically 3 different things on them that are useful information. Normally they'll tell you what type it is. So this is a Wilger nozzle. This is an MR. If you can tell me it's an MR, I automatically know what droplet size range you're in. It tells me kind of where you're at. If you tell me it's an AIXR versus a TTI, I know the very different designs that those nozzles are and what they're doing. Okay, so that's important. The 110 gives you the fan angle, right? So it's a 110-degree fan angle. And then the last number is the flow rate, which in this case, it's an 0.4. That means at 40 PSI, this nozzle gets me 0.4 gallons per minute. That is also what the color tells you. So the red color tells me I get 0.4 gallons per minute. So like I said, when you call and tell me I got the red ones, I'm like, great, I know your flow rate. I need more. Okay, so I want you to know that. There's all kinds of different types and how they're designed. The air induction versus non-air induction. The TTI, which has a turbulence chamber and does some different things with sprays, which we'll talk about in my presentation this afternoon. The main thing on this front, especially from y'all for mainly being consultants and agronomists in here, that I want you to know this and have a conversation with your applicators is sizing and how important it is to get the right size nozzles on your sprayer. So real quick, we're going to do a little bit of math. I apologize. Okay, I'm not a math guy either, but we got to do it for sizing. This equation is very, very important. Learn it, memorize it, save it, whatever you need to do. So GPA by the nozzle spacing by the miles an hour, and we divide it by 5940. So we got a little example up here. If we want to spray at 10 GPA, we have 20-inch spacing on our sprayer, and we want to travel 20 miles an hour. Now, I'm coming from Arkansas where 20 is slow. Okay? I know it's not the same up here, but let me tell you, Indiana 20 is basically slow at this point too. But that's the speed I picked just for this example, right? So if you do that equation, it comes out to 0.67, which means I have 0.67 gallons per minute that I need out of my nozzles. So with that result, you can either choose an 06, a gray nozzle, and operate it at 54 PSI. That gets you your output. Or you could pick an 08 nozzle, if you wanted, and get at 31 PSI and get that output. I'm good with both of those, right? They're decent pressure. You're getting your output. Looks good to me. If you've got a pulsing sprayer, you can operate that at 40 PSI and just keep it there, right? Because the pulsing, the way those operate is you just hold a constant pressure and it'll pulse to get your output correct. So what that does, we hold it at a constant 40 PSI, we stick a 10 on it. This is like the most common nozzle I see on those pulsing sprayers is a 10 size, so 1 gallon per minute. That's going to operate at about a 70% duty cycle. So basically it's on 70% of the time. I'm also okay with that. Now the problem comes in when we're not operating at 20 miles an hour anymore because all of a sudden we have to switch to our headlands, right? Or we get down somewhere where we're concerned about drift next to a neighbor or something else. So we shift down to 12 miles an hour rather than 20. Now if you run the math, we have to have 0.4 gallons per minute on this. All of a sudden that 06 nozzle is only at 18 PSI. That 08 nozzle is only at 10 PSI. They don't like that. They're not forming patterns. That's going to be ugly and streak the field. If you got a pulsing sprayer, you're still at 40 PSI. It's dropped down to only a 40% duty cycle. So it's only on 40% of the time. Those systems don't like that. They start doing weird things with spray patterns and droplet size and everything else. So the main message with this nozzle sizing, use that equation and don't just factor in your max speed that you want to run at all the time. Factor in the range of speeds that you're going to be traveling so you can pick a nozzle that'll sit in the middle that'll handle both. All right, that's important on this. You also need to factor in a nozzle that's probably going to handle different volumes if you're going to do different volumes, right? 10 GPA is very different than 15 or 20 with the sizing that you need and the speeds you want to travel at. So use that equation, make sure we're picking nozzles appropriately. All right, There's two places in the country where I can use a Brett Bielema meme and everybody will laugh at it. Arkansas and Wisconsin, right? So I just want to make sure, well, yeah, Illinois too, but nobody likes Illinois. So I just want to make sure that we are not looking like Brett Bielema, all right? Are we all not confused? Are we all doing okay? Okay. Everybody thank Ryan and Illinois for taking, Brett Bielema off our hands. We're all very appreciative. Thank you. I know. It's great. Appreciate it. All right. Real quick, dual fans versus single fans. I won't get into a lot of this, but there's a lot of talk about using dual fan nozzles. Originally, I was kind of a dual fan hater, all right, because we had done some research that showed dual fans didn't really get us any better coverage than some of our single fans. So this is the AI TTJ, a dual fan, versus the AI XR, which is a single fan. TTI 60, a dual fan, versus a TTI single fan. We didn't really get any better coverage, so I was kind of a hater about it. I was like, they generally are more expensive. We're not getting better coverage. I don't see the point. Did some follow-up research, though, and we looked at deposits, not just that coverage number, because we talked about that coverage number potentially being biased a little bit, right? This is where it gets interesting, is when you look at deposits on those cards, the dual fans are actually doing something. So the AI TTJ, that dual fan versus AI XR single fan, had a bigger droplet size by about 150 microns almost, and got more deposits on target for us. The same goes for the TTI 60 versus the TTI. A little bit smaller size, but got way more deposits on target. And the TTI 60, which is a bigger size by double, 600 microns versus 300, had equal deposits on that card as the AI XR. That's really promising for getting droplets to the target, right? And then if we looked at some weed control stuff, this was barnyard grass. Barnyard grass is a big deal in Arkansas, all right? If you look at panicle counts and you look at the seed production from those plants, those trends, if I back up real quick here, follow that exact inverse pattern, right? The ones that had the most deposits, the XR, had the least amount of seed production and the least panicle heads. The ones that had the most, or the least deposits, had the most seed production and the most seed heads. So there's more to these than just coverage. When we talk about coverage, and I've hit on it a lot today, there's still this deposit factor and these other things going on too. And I've actually kind of switched my script a little bit on these dual fans. I think we need some more research yet, but I actually feel a little bit more positive on them now. They are doing something else in the background there, even though it doesn't come through on coverage. It comes through on deposits and some on the weed control front too. So I'm not recommending to just like go out and buy all dual fans. Like, I don't want you to just do that, but just be aware they may be an option. They may help out in certain situations. All right, so now the selection is key. We hit on all that. Jesus, okay. We'll skip over aerial applications. We won't talk about that. This is when you know you got a good extension speaker. You just start speed running through stuff, all right? Okay, spray drones, real quick. I do have to hit on this though. We did a study. I'll be honest, again, I was a hater on spray drones. I was like, there's no way these things can work. We're going to make sure that we set these up for failure in this study so I don't have to talk about them and do research anymore. That was literally my goal with this study. Okay? So with this study, we were using a spray drone, a T30. So it is a little older technology now at this point, but a T30 at 2 and 5 GPA, comparing it to a Mudmaster ground rig, which is just kind of a small ground rig setup, basically, right? And we were operating that at 10 GPA, basically commercial comparisons, right? And we tested 3 different nozzles, an XR flat fan, a TADF dual fan, and a ULD High Pro. High Pro ULD. So basically a medium spray, about a coarse spray, and then like an extremely coarse spray. Got 3 different droplet size classes. I'll show you weed control in a second, but what we were spraying was gramoxone at a low label rate. And we had weeds that were basically knee-high. Told you, I was setting this up for failure, right? I'm going to show that this doesn't work, and we're going to be done with this. All right, when we look at coverage cards, when we look at a fine spray, we see what we expect, right? As we increase spray volume, we increased our coverage. Okay. So we went from 10% to 26%. Okay, yippee. Don't know about weed control yet, but we got better coverage, better chances there. But what was really interesting is when we look at the larger droplet sizes, when we look at 5 GPA versus 10 GPA, we had the exact same level of coverage. Drone, 5 GPA versus the ground rig at 10 GPA. That shows some promise that we got really good coverage coming out of that. It seems really effective. Now, the 2 GPA treatment had me a little bit worried because we never got over 5% coverage. Okay, that's a little bit concerning from a weed control standpoint. But let's get to where the rubber meets the road, and we talk about the actual weed control standpoint. Again, gramoxone, low label rate, pretty tall weeds. This is the aerial shot of it. The yellow boxes are 2 GPA out of the drone. Little bit of green, but not too bad. If we go to the drone at 5 GPA, looks a lot, I shouldn't say a lot better, but it does look better. I think you can pick it out that it is a little bit more brown, a little less green. And if we go to the Mudmaster, which is the black box, is at 10 GPA, I don't see much of a difference than that with the drone at 5 GPA, right? It looks pretty darn close, pretty darn similar. When we look at the actual data, the ratings at 4 weeks after said that the 2 GPA treatment lagged behind a little bit. So we got 70% control versus 85% control with the 5 GPA treatment from the drone and 10 GPA out of the Mudmaster. So 2 GPA lagged behind just a little bit. But what was interesting is there was no difference in biomass. And when we look at a greenness index 4 weeks after application, there was no difference in that greenness index. So I say that all to say a drone at 2 GPA too is honestly looking like it can do just as good of a job for weed control as 5 GPA or out of a drone or 10 GPA out of a Mudmaster. Now, please don't run away with this and tell it, like, again, say, we're good at 2 GPA for all drone applications. We're great. No, I'm not saying that, but this made me really rethink some of this. There's other things going on with drones, especially with gramoxone at a 2 GPA rate. That blew my mind, okay? So we got to do some more research and fine-tune these things a little bit more, but it does look like there is some opportunity here where they can do a good job and still get us weed control even at low volumes. Now, that's not talking about the label considerations, okay? That's a whole nother conversation, but just from a practicality standpoint, it does seem like they are a little bit feasible, which is really interesting. I do want to mention this, though. One complication with this. Oh, sorry, go ahead. Okay, so one complication with these spray drones, though, is the spray swath. Everything you do, whether it's a different drone, a different nozzle, a different flight height, a different wind direction and speed, your swath width is going to change, though. So this is where it gets complicated, especially if you're trying to do overlap in multiple passes, okay? So I bring that up to show this example here. The XR at 2 GPA, we just did this year at Purdue. The XR at 2 GPA, this is 30 feet wide. In the system, we said it was supposed to be a 20-foot swath. That XR at 2 GPA doesn't really look like a 20-foot swath, right? We got droplets all the way out for that full 30-foot, pretty consistent. When we jumped it up to 5 GPA, the way we did that was we just slowed it down, okay? So we changed our speed. It funneled all of that spray because it was going slower right into the middle. Now all of a sudden, our spray swath is maybe, 10, 12 feet or so, 15 feet at the most. So we're not hitting our 20-foot swath that we put in the system. When we went to a bigger droplet size, 2 and 5 GPA, the speed didn't matter as much for the big droplet size, but the bigger droplet size still funneled it in the middle, and we don't have a 20-foot swath there either. We're only sitting at about 10 to 15 foot or so. Well, if we're really only getting 10 to 15 foot, but our system thinks it's 20, you can see the problem, right? We're going to end up with skips in the field and streaks. So we still have kinks to work out. We can work them out. We just need some more time on these things. But again, there is more room for opportunity than I originally thought with these things, and we just got to kind of fine-tune them a little bit more. All right, technology. Here's my view of technology, right, for weed control. It's just dynamite it all. There is some really cool things. I won't talk about this very much, but the See and Spray or the One Smart Spray, where we're starting to detect weeds live on the go and only spray where we see them, okay? This is really probably the wave of the future. Now, we're still not there yet either. We still need some time on this front. We still got to work out the economics some on this. So there is still some room to grow, but there is a ton of market opportunities right now. I have lost count of the number of startups and venture companies that are getting into this weed control world. And so competition drives down prices. So 5 years from now, we're going to get there. It's just going to take some time. But there's a lot of opportunities here for either, more selectively managing weeds, reducing our total chemical output, which will be big for regulatory concerns in the Endangered Species Act moving forward, but also maybe reducing some of our crop injury, right? So we talked about cobra earlier, when we absolutely annihilate our beans for that week or two if we spray a full rate of cobra, whereas if we can selectively apply it a little bit, we can reduce some of that burn, and maybe those growers aren't calling us upset that their bean crop looks just smoked out there for a week or two. And then on top of that, there's just 100 other new technologies going on at this point that we're testing and is going to be the wave of the future. Weed control is drastically going to change over the next 5 to 10 years. The simple silver bullet of pick a herbicide and spray it and we walk away from the field is no longer an option or our future. All right. The pipelines for herbicides is very limited, and they're still quite a ways out. Several years, next decade kind of thing. So that's not going to be a huge thing. It's going to be a wave of these different technologies and integrated weed management strategies. So things like robotics, things like precision tillage pieces of equipment, which can sense the crop row, and maybe we can do some inter-row cultivation a little bit easier. Laser weeding, which is pretty cool, or even harvest weed seed control, stuff like that. Okay. Now, any last minute questions before I go even more over my time? All right. So with that, I'll just throw this up here. This should be my contact info. I also appreciate that nobody threw anything at me from being from Purdue today and wearing Purdue outfits. I stopped at Quick Trip and thought I was going to get shanked in there, but that's all right. So if you have any questions, I'm going to be here all day. I've got another talk this afternoon that will cover more on kind of the chemistries and some herbicide recommendations and some of the interactions between nozzles and adjuvants and things that we didn't really hit on this morning. So otherwise, any questions, please feel free to hit me up. Awesome. Thank you all.